Okay, so today we're going to be doing the genomic range query from Codility, lesson 5, prefix sums. Here's the question. A DNA sequence can be represented as a string consisting of letters A, C, G, and T, which corresponds to the types of successive nucleotides in the sequence. Each nucleotide has an impact factor, which is an integer. Nucleotides of type A, C, G, and T have impact factors of 1, 2, 3, and 4 respectively. You're going to answer several queries of the form. What is the minimum impact factor of nucleotides contained in a particular part of the DNA sequence? The DNA sequence is given as a non-empty string. S is equal to S of 0 to S of n minus 1, consisting of n characters. There are m queries, which are given in a non-empty arrays p and q, each consisting of m integers. The kth query, where 0 is less than k is less than m, requires you to find the minimum impact factor of nucleotides contained in the DNA sequences between positions p of k and q of k, inclusive. For example, consider the string s is equal to CAGCCTA, an array p, q such that p of 0 is equal to 2, q of 0 is equal to 4, p of 1 is equal to 5, q of 1 is equal to 5, p of 2 is equal to 0, and q of 2 is equal to 6. Answer these m equals 3 queries. The answer to these m equals 3 queries are as follows. The part of the DNA sequence between the positions 2 and 4 contain nucleotides G and C twice, whose impact factors are 3 and 2 respectively. So the answer is 2. The part between positions 5 and 5 contain a single nucleotide, whose impact factor is 4. So the answer is 4. The part between positions 0 and 6, the whole string, contain all nucleotides, in particular a nucleotide A, whose impact factor is 1. So the answer is 1. Write a function given a non-empty string S consisting of n characters, and 2 non-empty arrays p and q consisting of m integers, returns an array consisting of m integers, specifying the consecutive answers to all queries. Result arrays should be returned as an array of integers. For example, given the string s is equal to c, a, g, c, c, t, a, and arrays p, q, such that p of 0 is equal to 2, q of 0 is equal to 4, p of 1 is equal to 5, q of 1 is equal to 5, p of 2 is equal to 0, q of 2 is equal to 6, the function should return the values 2, 4, 1, as explained above. Write an efficient algorithm to solve this. Okay, so let's get started. Okay, so we're going to solve it in JavaScript, and just to recap, we're getting in on 3 variables. S is the genomic sequence. P is the starting part of the subsequences, and Q is the end part of the subsequences. So if we have a sequence A, C, B, A, C, G, T, we have to find the minimum, and we have, which would be S in this case, and we have a subsequence of, or subarray of 0, 1, and for Q we have 0, 0. Basically, the subsequences that they want us to analyze would be A, because P of 0 is equal to 0, and Q of 0 is equal to 0. So we're only looking at one character in S. So we're looking at S of 0 to 0, right, which would be S of 0, which would be equal to A. For the second sequence, which is P of 1 to a Q of 1, P of 1 is equal to 1, Q of 1 is equal to P of 1 is equal to, oh sorry, these are backwards, this should be like this, since P is the starting point. P of 1 is equal to 0, and Q of 1 is equal to 1. So we have S of 0 to 1, so we're going to have S of 0 plus S of 1 concatenated, and that would be AC. Because we're looking at for this array, because we're looking at the subsequences within the string. Furthermore, we're looking for the impact factor, associated minimum impact factor, right? So impact factor is A is equal to 1, C is equal to 2, G is equal to 3, and T is equal to 4. So what we want to find in the sequence that is returned in both these cases from the string that was isolated is the minimum impact of that string. So in this case, the minimum impact would be 1, since A is equal to 1. And in the second case, since we have A and C, and A has a smaller impact factor than C, the impact factor will be 1. That would be the minimum impact factor. Equal to 1. So now we're going to write an efficient algorithm that will be able to solve that. So let's think about the steps. 1, we'll calculate the prefix sum. Prefix sum for A, C, G, and T. Here's something to note about the prefix sum that I've noticed. Other people may have other opinions, but I've found it's only good for getting the cumulative value of one point of focus. So for example, A, C, G, and T will all need their separate prefix sums isolated. I haven't come across a situation where you had to compensate for more in a single prefix sum array. So we're going to calculate this prefix sum for A, C, G, and T. Then based on the entire genomic sequence. Next, what we're going to do is iterate through the subsequences given, P and Q, and we're going to create an array consisting of the minimum impact factors for the isolated subsequences. Okay, so cool. So the first thing I'm going to do is define a hash map, or a hash that will contain the impact factors. So A will be 1, C will be 2, G will be 3, t will be 4. Okay, cool. So we have a hash of the impact factors that we can always reference to. Next, we're going to iterate through the actual sequences. So we'll start at 0, and while I is less than p dot length, I plus plus. And here we're going to have all our subsequences, right? So we will have a function in order to calculate for us our minimum impact factor, because this is a consistent operation we're going to need to do. Get min impact, and we'll pass in the position of the subsequences of the actual subsequences that we want to analyze. And from that, what we're going to need to get is the start of the sequence, which would be p of position, and the end sequence, which would be q of position, because these define the outer bounds of the actual subsequence within the major sequence, which is S. Okay, so based on this, we still need to get our prefix sums, and that should be done at the beginning, even because this is where we're going to be iterating through our subsequences. And so we're going to calculate the prefix sums. So we're going to need arrays to hold the values of all our prefix sums. So we're going to have our A array is equal to new array of how many values? Let's think. So we're going to have our S length is equal to S dot length, and we're going to need a prefix sum array of S length plus 1 for, and we're going to fill it all with zeros, because the prefix sum by default of everything before it's been calculated is going to start off at 0. Okay, so we're going to do that for all our genomic sequences A, C, G, and T. Now, while we're calculating our value, actually let's do this. S length is equal to that because we're only going to use it once. Okay, so now we're going to also need a running count of A, C, G, and T. This is going to be what's calculating our prefix sums. T. Okay, cool. So now what we're going to do is calculate our prefix sums. Well, I is less than S length, I plus plus. So we're going to start off at 1 because the initial prefix sum is always going to be 0 before we start taking into consideration everything, right? So let's start calculating. If S of I is equal to A, that's S of I minus 1, what we're going to do is do running count of A plus plus, and we will keep this calculation. So this is going to give us allow us to fill in our prefix sum. Arrays. This is actually, in my opinion, I think this is a hard question, but yeah, this is how you understand concepts, by dealing with difficult problems like this. It really tests whether you understand what prefix sums are needed for. Okay, so now we have a running count of A, C, G, and T, right? And every time we go through our array, we're going to use this, iterate through this loop. We're going to use this in order to fill in the value, the current value of the element we're on. So that would be A of I is equal to running count. C of I is equal to running count is C. G and T. G and T. Okay. G and T. So now we got our prefix sum array all calculated up, and it's going to go to start off at 1 and go to s.length. Okay, so now we're going to use that and use it in order to calculate our min impact based on the subsequence is equal to get min impact, and we'll pass in our position, which is I at the moment. So now let's go to our sub function, our nested function, get min impact, and let's see what we need to do here. So here's where we're going to calculate, and let's use a console.log to tell, so that we can use this we can look at this in our console to track our program, right? Okay. Also, our end sequence is not going to be queue of position, it's going to be queue of position plus 1, because that's just how prefix sums work, because we're going to be subtracting the queue position from the peak position of each of the arrays in order to see if the A, C, G, or T exists in that particular sequence. So if A of end sequence minus A of start sequence is greater than 0, we're going to return our hash. So that would be the hashes we defined here. We could just return a 1 and stuff, but I'm just using this for clarity. So that'll be our impact factor for A. Okay, let's do it for the rest. 2, 3, 4. And this would be C, G, and T. C, G, and T. Okay. So, we don't really even need this if statement, because everything else fails here. We know it's going to be a T. So we're going to get our impact factor, and we will need an array for our response. Result equal new array of e dot length, and I guess we'll fill it with zeros. Okay, and yeah, we'll just do result of I is equal to min impact. We fill it out, and we'll return our result. Okay, let's see how that goes. Okay, so it's saying we're okay. I don't think I got it on my first go. I probably made a logic mistake. I can't think of any edge conditions that I have to compensate for. So, yeah, let's see. It's passing the test cases. Let's see what happens. One of the problems I had with this question is I skimmed it initially, right? And I would always answer the question. I tend to rush myself, and I would always answer the question I think they're asking rather than the question, or they should be asking, rather than the question that they are asking. So it's very important to always read over the question prior to starting any question. So as you can see, we got 100%, and we used prefix sums. So there were a couple of key takeaways, and that one of them is that prefix sums are best done, could be used in different ways, and I find it simpler to isolate particular things you're looking for and calculate the prefix sum based on that. Otherwise, things could quickly get confusing. So yeah, that was the Codility Lesson 5 prefix sum genomic range query question, and we scored 100% on task and correctness and performance. So till next time, I'll put the question description in the description box below.